So we're going to start 1.3. So remember, chapter 1 is review. It's some stuff you remember, but it's been a little while. I'm going to focus on kind of the weird topics, but I'm going to kind of go through. 1.3 has like 53 slides, so we're going to go a little at a good pace. And the goal is to get through 1.3 and 1.4. Okay? So we're going to talk about mathematical modeling, linear equations, functions and inequalities, quadratic functions, equations and inequalities, properties of quadratic functions, applications of linear and quadratic regression. What we do for linear regression is the same stuff, Leslie, that we do for quadratic, cubic, and all the rest. Okay? So math modeling is the process of using mathematics to solve real-world problems. There's 3 steps: construct the model, solve the model, and interpret the solution. So basically, you set it up, solve it, and make sure it makes sense. Each step should be done in the context of a real-world problem. We have a graphic where we construct, solve, and interpret. Okay, so linear. How do we know if something's linear? Well, it's in the form ax plus by equals c. Bottom line, a plain old x, a plain old y, then you have a linear. There's no squared or cubed or anything like that. A, b, and c are constants, and a and b are not zero, both zero. Okay, so you've seen this. This is called standard form. Ax plus by equals c. A, b, and c are constants. A and b are not both zero. X and y are the variables. And if you graph it, it becomes a line. If a is 0, which means the x is gone, and we have y equals, you'll get a horizontal line. If b is 0, that the y is gone, you have x equals, that's a vertical line. You can graph it on the plane. Another thing to remember is slope formula. Remember, slope is y2 minus y1 over x2 minus x1. That's slope formula. Given 2 points, you can find the slope. All of you remember doing that. And then if the slope is positive, from left to right is going up. If the slope is negative, from left to right is going down. If the slope is 0, you have a horizontal line. And if it's not defined, it's a vertical line. It doesn't quite make sense. Okay, you remember standard form is ax plus by equals c. What you mostly remember is slope-intercept form. Y equals mx plus b. That's the one you probably remember the most, where m is slope, b is the y-intercept. There's a couple other ones like point slope form. Y minus y1 equals m times x minus x1. And the reason why it's called point slope is in order to fill it in, you need a point, x1, y1, and you need the slope, m. But they're all linear. Standard slope-intercept form, point slope form, all the same stuff. If you have a y equals, it ends up being a horizontal line. X equals, you have a vertical line. If you want to find the x-intercept, you make y 0. If you want to find a y-intercept, you make x 0. And you're like, I don't want to do all that. That's good. Okay? So if I had a slope of 3 and a point, I can fill in the point slope form. So if I had the slope is 3 and a point 2 comma 5, remember slope-intercept, a point slope form is y minus y1 equals m x minus x1. So where would I put the 3? In for m. Where would I put the 2? In for x1. Where would I put the 5? In for y1. Boom. Okay? All stuff is made just for a little while. Take notes, whatever you need. But that's called point slope form. Now, I can take that and solve for y. Move it over. Add 5 to both sides. Make it y equals. And then I get slope-intercept form. Same thing. Point slope form, one way to write it. Slope-intercept form, another way to write it. They're all just lines, different ways to write it. Or if I move that 3x over, subtract 3x, now I have standard form. Negative 3x plus y equals negative 1. But standard form, slope-intercept form, point slope form, it's the same line over and over and over again. It's just 3 ways to write the same thing. Okay? So a linear function, instead of y, we use f of x. So if I told you a student organization is planning an event and intends to sell custom printed t-shirts, the t-shirt committee found a company that will create the artwork for a fee of $175. The company will print the shirts for different sizes for $4.75 per shirt, and the organization plans to sell shirts for $12 per shirt. We kind of went over this last time. I want you to write down what is the cost function, C of X, and what's the revenue function, R of X. Given that information, write down the cost function, write down the revenue function. Cost function, revenue function. Cost function, revenue function. You know that there's a flat fee of $175 for the artwork. Each shirt is $4.75, and you're going to sell it for $12 per shirt. So write down what would be the cost and what would be the revenue. Cost, revenue. Give you a couple minutes. If I didn't mess with your calculator, raise your hand. Anybody else? Calculator? Got one more minute. All right, so let's kind of look at this. What would the cost be? What would the cost be? 175 plus 4.75 X. Perfect. You got to pay the 175 plus 475 per shirt. X is number of shirts. I have no idea how many. So X, number of shirts. The cost, C of X, would be 175 plus 475X. If somebody put 475X plus 175, is that also correct? Same thing. And what would the revenue be? What would R of X be? 12X. Perfect. And kind of like we talked about last time. Fixed cost is 175, variable cost is 475. So the cost, C of X, would be 175 plus 475X. If you wrote C of X equals 475X plus 175, same thing. Since you're selling each shirt for $12, the revenue would be 12X. Now, are both of these linear? Are both these quadratic? If I graph these, what would they be? Both linear. Why? How can we look at it and know it's linear just like that? Plain old X. Plain old X, plain old X. Not X squared, not X cubed, plain old X. It's going to be a line. Okay? So we have our two functions. And if I wanted to find break even, how many shirts I need to break even, revenue has to equal cost. So I want you to take your revenue, set it equal to your cost, and find out how many shirts do I need to break even. How many shirts do I need to break even? So set your revenue equal to your cost. This is that algebra refresher. Make sure we know how to solve. So we take our revenue, which is 12X, equal our cost, and solve for X. Anybody else's calculator I need to set up? So to solve this, what am I going to do first? Subtract 4.75x from both sides, which gives me what? 7.25x equals 175. Stop there. Now, how do I get x by itself? Divide by 7.25. Divide by 7.25. X equals 24 what? Factors are decimal. Okay, if we divide, we get 24.1379. So basically 24 what? Well, it is 24 shirts.
Well, we're going to do 25.
It would be a little under, but if around 24 or 25, 25 we definitely get it covered, but around 24. Okay? So if I graph these, this would be a line, this would be a line, and where would the two lines cross? At about 24 shirts. Okay? And if you want to talk about money, if I plug in 24 into the revenue, let's just stick with 24. It won't be exact, but it'll be close. And I plug in 24. Let's see what we get. 288. Really. Now again, the exact answer, really close. Okay, linear. These are all examples of linear. All examples of linear. Okay? Again, if you're like, I don't remember all this, great. Now, other thing I want to remind you of is something called interval notation. We kind of talked about it last time, but I just want to remind you again. Interval notation is a convenient way to represent a collection of numbers that are given as inequalities or as number line graphs. Okay? So there's a couple ways we can talk about it. Okay? Let's say your answer is from A to B, and A was included. If A and B are included, we use brackets. Now, if A was included but B was not, A would have the bracket, B would have parentheses. That means up to it but not included. Other way around, A up to but not including A, but including B, bracket, bracket. If it went up to but didn't include A and B, we use parentheses. If it goes to the left forever, like negative infinity, that's always parentheses, but included A would have a bracket. One including A, we put parentheses. And again, on the other side, it's positive infinity, including B to the right to positive infinity, so always parentheses, not including B, parentheses, to infinity. This is interval notation. Or you can do it as an inequality. So for example, x is greater than or equal to A, but less than or equal to B, brackets on the interval notation. If I wanted A included, I put a line underneath it saying included A, B not included, doesn't have the line. If they're both not included, they both don't have the line. Or you can say A is less than or equal to A is included, X is less than or equal to A is not included, so forth and so on. That's inequality notation, and then you may or may not have seen the line graph. A to B included, bracket, shade everything between. A is included, bracket, B not included, parenthesis, all the way down. If you want to show to negative infinity, you kind of fill in the line to say it keeps on going. A is included, bracket. A if not included, parenthesis. If B is included, bracket, positive infinity, you shade all the way in. Parenthesis, not included, all the way to the right. You guys are like, I remember all that. Yep. So.
Like circles instead of
another way is if you fill in the circle and not fill in the circle, it's another way.
Right. So bracket means filled in circle.
Bracket would be filled in circle. Open circle means up to but not included. Good point. There's a lot of ways to show it. Endpoints, intervals closed if it contains. Now we're going to talk about x squared. If I said x squared, would this be linear anymore? What would it be? Quadratic. Right? And what shape would that be? Parabola. And you're like, I remember all that. Great. We went over that before in 1.2. The shape would be called a parabola. The shape would be called a parabola. Quadratic. Remember doing that for 1.2. And a quadratic function would be ax squared plus bx plus c It's standard form for a quadratic. It would be a parabola. Notice a cannot be 0 because if a was 0, there'd be no x squared, it'd be linear. The domain is all reals, the range is all reals. The x-intercept is when the function is 0, when y equals 0. If I want to find the x-intercepts. So to find the x-intercept, you set it equal to 0, solve for x. And you may remember this wonderful thing, what is it called? Quadratic formula. Quadratic formula is to find x-intercepts. Quadratic formula is to find x-intercepts. Quadratic formula to find the x-intercept is negative b plus or minus square root b squared minus 4ac all over 2a. All this is to find the x-intercepts. Another way, that standard form is ax squared plus bx plus c, that's standard form. There's also vertex form, okay? So if I have a times x minus h squared plus k, if you can get it to this form, h, k would be your vertex. Remember, your vertex is the highest or lowest point. If you can get it to look like that, you can pull out the h and the k, and it's vertex. But I do want to point out that it's x minus h. You got to have that minus in there for it to work. Very particular form. We'll talk about it a little bit, but I don't want to stress too much about that. In order to get it that way, we have to do something called completing the square. We can also find it with the calculator, which I'll show you all of that. Okay? So this is where we may have a little trouble today, but I want to go nice and slow. Okay? So if you wanted to change this standard form into vertex form, here's what you do. Let me go over it, and then I'll teach you how to do it. So first of all, we have to get that 3 out. So to get that 3 out, notice in the first two, I can factor out a negative 3, just in the first two. I factor out a negative 3, so I have x squared minus 2x. If I bring it back, negative 3x squared plus 6x, that's where it comes from. But in order to get vertex form, the x squared has to be 1. A has to be 1, so we pull it out, and then we leave the minus 1 alone. Step 1. Again, don't stress too much about it. We're going to go over it. Then, the whole point is to get this into like a perfect square. So if I add 1 here, this will be x minus 1 squared, which will get it in the form. But I can't just add 1 here because I feel like it. If I add 1 here, it will help me in the future, bear with me. But what's negative 3 times plus 1? Negative 3. How do I cancel that negative 3? What's the opposite of negative 3? I have to add 3 at the end. I got to make sure my equation stays equal. So negative 3, how do I get rid of that negative 3? You add 3. I know that's weird, but let me show you why. The whole point of this is that now this can be factored. X squared minus 2x plus 1. That can be factored into x minus 1 squared. X minus 1 times x minus 1 is x squared minus 2x plus 1. Now again, that's a lot of work. Negative 2 plus 3 is, negative 1 plus 3 is 2. But if I can make it look like this, what's the vertex going to be? 1, 2. But you got to get all the steps to get there. But if you can get it, you can find the vertex like that. You can find the vertex like that. Again, I know it's weird, but if you can make it look like that, the vertex is 1, 2. Now you're like, let's practice. Okay? So again, we set it equal to 0. This is a little different than the last one. So let's do this one together. Okay? And again, the last one, that was the same one. Okay? Now, another way of doing it is with quadratic formula. So you may be wondering what I just did to your calculator. Well, before I show you that, a way to find the x-intercepts is to set the function equal to 0, which means we can do a quadratic formula. Which number is a? Negative 3. What number's B? 6. What number is C? -1. Good. If I plug it in, negative B plus or minus B squared minus 4AC all over 2 times A, it will give me this answer. -6 plus or minus square root of 24 over 6. And then 1 with a plus, you get those 2 answers. 1 with a minus, you get 0.184, and you get 1.816. Are we okay? You want to see a much faster way to do that? Okay? So, you back up. The function is negative 3x squared plus 6x minus 1. We talked about how to do the vertex using the vertex form, and we talked about how to do quadratic forms. We talked about both. What's A again? What's B again? And what's C again? So to find the x-intercepts, we set the equation equal to 0, and we do quadratic form. Everybody with me? Go to your calculator, and I just installed the program. Okay, you can get this program online as well, but I just installed it for everybody. Turn on your calculator, press the program button, PRGM right here, program, and you should have a program called quad form. Now, I taught you how to do it by hand with the vertex formula. I showed you the quadratic formula by hand. So we all knew how to do it by hand, right? Hit the program, press enter. What's the first question? A. What's A? Now, negative is the button on the bottom, so be careful. Put in -3, enter. What's B? 6, enter. What's C? -1, push enter. Now, what is the calculator doing? The same thing. The same thing. I'm showing you this because this class is what? What's the name of this class? Business calculus. It's not college algebra. College algebra is where you learn quadratic formula, vertex formula. I'm refreshing your memories, right? But you've all been taught it. But the vertex is 1, 2, and your x-intercepts are right there, the solutions. Are we okay? So you have your calculator to do it for you. Why your algebra teachers didn't teach it to you? Sorry. Okay? But were you taught this in college algebra? Yeah. Not the program, but the how to do it. Yes. Okay? So, but again, I'm trying to remind you, refresh, how to do all this. Okay? So there's your vertex formula, A parenthesis x minus h squared plus k. If A is positive, it's a happy face, opens up. If A is negative, it's downward, sad face. The vertex is at h comma k. Axis of symmetry is x equals h. That's where the left and right sides match. So let's practice this. Remember, vertex is the highest or lowest point. If it's a sad face, it's the maximum. If it's a happy face, it's the minimum. Here's what I want you to do. I would like you to take this one, and let's practice a couple things. I want you to find the vertex, and I want you to find the x-intercepts. So here's one for you to practice. Use your program. Find the vertex and find the x-intercepts. Now, we'll talk about the inequality in a minute, but let's use this as practice first. So let's pretend it would just equal 0. We'll worry about the inequality part in a minute. Let's pretend it equals 0. I want you to tell me the vertex, and I want you to tell me the x-intercepts. Practice, practice, practice. So basically, we're just reviewing quadratics. And be careful. I asked for vertex, and I asked for x-intercepts. I asked for x-intercepts. Be careful. So, what's A? -1. What's B? What's C? Any questions so far? Now, I'm using the calculator, but again, I'm only using the calculator because you know how to do it by hand. Program, quad form, enter. A is -1, enter. B is 5, enter. C is 3, enter. Now, please be careful. What is the vertex? 2.5, comma, 9.25. Are we okay? Listen to the question. What is the first x-intercept? Round it off. Is 5.54 an x-intercept? No. X-intercept would be 5.54, comma, 0. An x-intercept is a point. An x-intercept is a point. What's the other point? -0.54, comma, 0. So just remember, x-intercept is a location, a point. It's when y is 0. Are we okay? But I'm not stopping there. This is a review. If I was to graph this, what shape would it be? Parabola. How do you know? X squared. Is it a happy face or a sad face? Sad face, how do you know? A is negative, the number in front's negative, so I know it's going to be a sad face parabola. Are we okay? I want you to graph it in a window from -10 to 10, -10 to 10. So, to remind you, which we already went through last class, how do you graph this? What am I going to do? Y equals, if you have a plot on like I do, see how plot 1's on? Make sure it's off. Hit enter. Plot 1, plot 2, plot 3 should all be off. Last class we talked about this. -x² plus 5x plus 3, enter. Because we have it equal to 0, and I'll show you something in a little bit, make sure y2 is 0. So, y1 is -x² plus 5x plus 3, y2 is 0. All the plots are off. Work with your neighbor, we're learning the calculator. We good so far? Now, I want a standard window, -10, 10, -10, 10 for x and y. So hit zoom 6. Zoom, and then the number 6. That's a quick way to get a standard window. Zoom 6. Did you get a parabola, sad face? Are we okay? On this picture, we have a vertex, the highest point, and we have 2 x-intercepts. Are we okay? Now I'm going to teach you how to do all of that in the calculator. Are we okay? Number 1, and we did this last time, we're reviewing. How do you find the vertex, which we already know is 2.5, 9.25? What do I press? Second trace. Take notes. We're trying to find vertex. It's a sad face. So what would vertex be called? Maximum. Number 4. And then we answer the questions. What's the first question? Left bound. Go anywhere to the left of the vertex, press enter. Second question. Right bound. Go anywhere to the right by pushing the right arrow. Anywhere to the right of the vertex, push enter. What's the last question? Guess where you think it is. Put your cursor where you think it is, hit enter. Now, notice the calculator, because it's the calculator. 2.4999999 is really what? 2.5, comma, 9.25. You know how to do it by hand. You know how to do it with a program. And now you can do it with a calculator. And we went over it again. If you forget, I'm going to now expect you, find the vertex, take out your calculators. Are we okay? Now the x-intercept is where it crosses the x-axis. Crosses. That's why, to find where 2 lines cross, y1 is the equation, y2 is 0. You have to have y2 0. Are we okay? How do you find the intercepts? What do I press? Second trace. Which option? Intersect, number 5. Choose 5, and then what?
First.
Do you remember from last time? Enter 3 times. Enter, enter, enter. 5.54, comma 0. How do you find the other one? Second trace, number 5, but it's going to keep finding the same one. So what do I have to do? Move it over, left, 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 left. Move it over to the other side. Once it's closer to the other one, then what? Enter, enter, enter 3 times. Have we gone over all this? Okay. Now, draw a quick sketch on your own. You know it crosses at negative 0.54. You know it crosses at 1, 2, 3, 4, 5.5 here. And you know the height is 2.5, 1, 2, 3, 4, 5, 6, 7, 9. You understand all those points. And let me go back to the original question. The original question was, when is the graph greater than or equal to 0? The original question was, when is the graph greater than or equal to 0? I'm going to give you a minute or two. Now that you have the picture, now that you know the vertex and the x-intercepts, see if you can write the answer in whichever interval notation you prefer. What's the answer to when is the graph greater than or equal to 0? Don't say it out loud. Have the picture. When is the graph greater than or equal to 0? 0 is the x-axis. 0 is the x-axis. Using interval notation, your choice. Interval notation, your choice. Which graph? Okay. When is the graph greater than 0? Is it above or below 0 when I say greater than? Above. So this is my answer. This is my answer. Everything above 0. Where does that answer begin? Negative 0.54. Comma, where does that answer end? 5.54. Are these points included? How do you know? Equal to. So what am I going to put around these? Brackets. Anything between negative 0.54 and 5.54 would be an answer. Now another way to write it, if you prefer, would be this way. Where my answer is anything greater than negative 0.54 or less than or equal to 5.5. Question?
Shade inside
In the calculator?
in the
Oh, everything wrong? For this, though, it's saying what answers are true. It's anything on that line would be true, right? So would a point in between here make that true? Remember, it has to equal 0. So really the line we're looking for. When is the line above 0? Okay? So this is connecting quadratic, interval notation, all the stuff we've learned, but I'm reminding you calculator, I'm reminding you quadratic formula, I'm giving you all the tools on how to do this, okay? And if you're like, oh yeah, I remember doing all this stuff, great, that's the whole point of this. So going back to the notes, they're showing you how to do it in the calculator, which we just did. They're showing you the x-intercepts, the interval notation, and there's other things. Okay? This is another example. At Macon, Georgia, peach orchard farmer now has 20 trees per acre. Each tree produces on average 300 peaches. For each additional tree that the farmer plants, the number of peaches per tree is reduced by 10. How many more trees should the farmer plant to achieve maximum yield of peaches? What is the maximum yield? I'm just going to go through this as an example of maximization. So to find the yield, it's the number of peaches per tree times the number of trees. So that would be 300 times 20, which is 6,000. If one additional tree is planted, according to the information, the yield per tree decreases by 10, and the number of trees increases by 1. So if I plug in decreases by 10, increases by 1, it changes to 6,090 peaches. Again, don't stress too much about the detail when we get to the equation part. So if 2 more trees were planted, if we plugged in 2, then you get 6,160. And I come up with the equation, negative 10x squared plus 100x plus 6,000. Is this quadratic? Good. Happy face or sad face? Sad face because a is negative 10. And we're going to go through and really from the equation practice what we just learned. So don't worry too much about the background. If we wanted to find the vertex, let me walk you through. Again, walking you through, we're going to use the program, we'll use the calculator, but I want to do another example. If I want to change it to vertex, look at the first 2, what would I factor out? 10 or negative 10? Negative 10. And again, step by step. If I factor out a negative 10, can everyone see how we get from step 1 to step 2? Now, the way to do completing the square is you take the middle term, negative 10, divide by 2, negative 5, and square. So what's negative 10 divided by 2? 5. 5 squared is 25. That is what makes a perfect square. So where did the 25 come from? Negative 10 divided by 2, which is 5. 5 squared is 25. Why did I do that? Because this will now factor into x minus 5 squared. X squared minus 10x plus 25 will factor, all of you have been practicing factor, appendix A, x minus 5 squared, but I added a 25. Really, I didn't add 25. I added negative 10 times 25. So what's negative 10 times 25? Negative 250. What's the opposite of negative 250? Add 250. That's where this came in. Again, step by step. That gives me from standard form to vertex form. And now, if it's in vertex form, I'm not going to spend too much time on this, what's the vertex? 5, 6,250. Are we okay? Find the vertex in the calculator. Find the vertex in the calculator. Again, we're doing it by hand, and we're doing it in the calculator. Find the vertex in the calculator. Find the vertex in the calculator. We can do it by hand, we can do it in the calculator, and we can do it by the graph. We have all these different ways of doing it. So, in the calculator, I go to stat, program, quad form, enter. What's A? Negative 10. What's B? 100. What's C? 6,000. And what is my vertex? 5, 6250. It also gives me solutions. What are solutions again? X-intercepts. Okay? Again, this is just for practice. The more we do, the better we get at it. So the maximum yield of 6,250 peaches is obtained by planting 5 more trees. Maximizing will be the vertex. Yep.
How come it's 5, but you make that equation is negative 5?
So how did I get negative 5 here? So if you factor x squared minus 10x plus 25, it would be x minus 5 times x minus 5.
Right. No, I'm saying. The A says minus 5, but then the A says right.
Oh yeah. So remember, vertex form, you take just the number, not the sign. So h, comma k. Good question. It has to be x minus. That's just part of the formula. But whatever the number is, without the sign. Good question. And again, if you have questions, just ask. Better just take care of it. Okay? Now, I want to practice doing it in the calculator, so I'm just going to give you the window. So let's go to y equals. Let's go to y equals. Change it to our equation. What's our equation again? Negative 10x squared plus 100x plus 6,000. You can leave the 0 in there. We don't really need it. But we're not going to use a standard window this time. We're not going to use a standard window this time. I'm going to provide you with a window. So let me tell you what the window is based on the problem. Remember the vertex? What was the x number? What was the x number? 5. So I'm going to go to window. Since I know the answer is 5, I'm going to go from 0 to 10, counting by ones. I know the answer is 5, so I put 5 right in the middle. Are we okay? What was the y number? 6,250. So I'm going to start with 0, but I need to go high enough in my y to cover 6,250. So what should I go up to? 10,000? And if you're counting from 0 to 10,000, what would you count by? Probably thousands. So let me stop here. The window wasn't given, but I figured out the window based on the answer. Since I want to see 5 in my x, I went from 0 to 10. Since I want to see 6,250, I went from 0 to 10,000. Are we okay? Hit graph. Now, using the calculator, find the maximum. Using the calculator, find the maximum. So again, we did it. We practiced it. Now, do you remember how to do it? So the more examples we do, the better you'll get at it. Find the vertex using the calculator. Find the vertex using the calculator. And it should be the same answer, 5, 6250. Again, we have to decide, are you following along and copying, or can you do it on your own? I'm great at this stuff. We're going to get you guys to do this. So we hit second trace. Which one are we looking for? Maximum, number 4. Go to the left of it, enter. Go to the right of the maximum. It's a little tough to see, but to the right of it, enter. Guess what you think it is? Enter, and you get 5, 6250. It's just practice, practice, practice. And when we start doing chapter 2, I'm going to say, find the maximum. I'm not going to say, second, trace, 4, left, right, yes. You have to know how to do it. You okay? Practice, practice, practice. Okay? So, quick review, the vertex is 5, 6250. The farmer should plant 5 additional trees to get the maximum yield of 6250. The vertex is the maximum. Okay? Let's talk about break even. If I wanted to find out where your revenue and cost are the same, I have my revenue function, x times 94.8 minus 5x, and I have my cost, 156.19.7x. I'm just going to kind of go through this one quickly as another example. To find break even is where the two lines what? Intersect. So I said revenue equals a cost. I'm just going to do this one quickly. Remember, this is a long section. I said revenue equals a cost. I solve for x, and we have a quadratic equation. Okay? So what I'd like you to do is there's your quadratic. If I'm trying to find out when it equals 0, am I looking for vertex or am I looking for intercepts? What am I looking for? Vertex or intercept when it equals 0? Intercepts. Find the intercepts in the calculator for negative 5x squared plus 75.1x minus 156.0. Again, it's just practice. Just practice. In this case, we're looking for when it equals 0. I know I went quickly through the scenario because I'm trying to practice the calculator. And in this case, we're trying to find x-intercepts. X-intercepts. When will the revenue equal cost? What will my x have to be for by revenue equal cost. Practice, practice. What do we do? What do we do? Okay, in this case, what's A? -5, B is, and C is -156. Go to our program, quad form, -5 is A, 75.1 is B, C is -156. This time, do I want solutions or vertex? Solutions. So we could break even at either 12.53 or 2.49. So, good question. In this problem, you could have done quadratic formula to solve, and x equals 2.49 or 12.53. Remember what x is. X is how many cameras. So the company breaks even when they manufacture either 2.49 or 12.53 million cameras in this case. Now, we're going to do this graphically. So remember, our revenue is 156 plus 19.7x, and our cost is what was our cost? The revenue is so we're going to graph the revenue and we're going to graph the cost, and we're going to find where they intersect. So in your calculator, I would like you to put the revenue in Y1, the cost in Y2. Put the revenue in Y1 and put the cost in Y2. So these are given. The revenue in Y1 and the cost in Y2. Now, I'm going to give you the window this time, but later on we'll develop the window together. But for right now, in Y1 we have the revenue, which is linear or quadratic? Quadratic. Happy face or sad face? Be careful. A is -5. So happy face or sad face? Sad face. Is the cost linear or quadratic? Linear. So in your mind, the revenue is a sad face parabola. The cost is a line. Is the line going up or down? How do you know the line's going up? Upward. Slope is positive. Good. These are what we're learning today. Now, I'm going to give you the window. Normally we figure the window out, but for right now, we just give you the window. So x minimum 0, x max 20. We can do a scale of 5. Y minimum 0, Y max 500, Y scale 100. And when you hit graph, I want you to locate where the revenue and the cost are the same. When you hit graph, draw it and find where the revenue and cost are the same. You already told me the answer should be 12.53 and 2.49. We're going to find it graphically. So after you put in the window, hit graph, draw, and find it. Everybody got the window? That's what it should look like. There's your revenue, sad face parabola like we talked about. There's your cost, upward moving linear. Find where the two intersect. So draw and label. Draw and label. Remember, you want to be able to do this at home as well. Yep.
Well, I don't think we need.
Does yours not look like that? Bring it over. Just remember one little detail to throw this off. Okay. Now again, in this case, are we looking for maximum or are we looking for intercept? Intercept. Different problems require different things. And we're finding both. Practice, practice, practice. If you need help, raise your hand. I know we're doing a lot today, but if you think about it, it's the same thing over and over again. So we do a lot of examples. And I'm showing you how to do it by hand, program, and graphically. All three. So, there's your picture. What do I press to find where they intersect? Second trace. Intersect. Enter, enter, enter. It finds one of them. 12.53. To find the other one, second trace, intersect. Before you hit enter, 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 move it to the other side. Once it's closer, enter, enter, enter. So again, by hand, using the program, and graphically. And just by a show of hands, raise your hand if you've done all this and call it out. About half. About half. Okay? Again, some teachers don't do all the calculator stuff, some teachers do. So I don't want you to be at a disadvantage. Hopefully you're appreciating the calculator stuff. And you can see what the answer is. Revenue equals cost. It's where they intersect. Quadratic, what it looks like. Linear, what it looks like. Okay? Yep.
What does it mean to have two break even?
Yeah, so let's think about it. If you sell at this price, you break even. If you sell at this price, you break even. So if you look at the graph, I would make no money but survive if I charge $2.49 or if I charge 12. I'm just going to change the example a little bit. If I produce 2.49 or 12.4. Now, is my goal to make no money? What's my goal? To make money. So the question is, I need to sell more than 2.49 to make money. But it needs to be less than 12.5. Now you're thinking the more I sell, the more money I make. But there's a point where I can't produce anymore. So I know I make money between 249 and 12.5. I can't produce more than 12.5. Then I have to hire somebody else. I got to open a new factory. I lose money at that point. But I have to sell at least 249. So if I know my 2 break-even points, that's the first step. The second question is, where do I make money? This part here. And then where I make the most money is another question. That would be vertex. That make sense? So break-even is just no money, and it could be 2 points. If I produce at least this or most this, that helps. Does that help a little bit? And again, ask these questions, because the questions you're asking are good ones. The why question is the most important. Okay? So we set all this up. We set equal to 0. We did quadratic formula. We worked it all out. And we're able to do it in the calculator as well. Okay? We found the 2 intersections. The company should manufacture either 2.49 million cameras or 12.53 million cameras to break even. Anything between those would make money. Your revenue would be above your cost. Now, linear regression is trying to find the line of best fit. What we're going to do now is very, very important. I'm going to go very, very slowly. And the reason why I'm going to go very, very slowly is the way we do linear regression is the same to do quadratic regression, is the same to do cubic regression, is the same to do quartile regression, logarithmic regression, exponential regression. If you get linear, you get them all. Are we okay? So nice and slowly with your calculator. An automotive tire manufacturer collected the data relating tire pressure, X, in pounds per square inch, and mileage in thousands of miles. The data in the table shows this data. So X is pounds per square inch, Y is miles. Step 1, we're going to put this data in our calculator. Okay? Slowly, slowly. So all together, go to your calculator. Since we have a brand new problem, let's start with a clean calculator. How do I start with a clean calculator? Everyone go to y equals. Get rid of y1. Get rid of y2. And please stop me if I lose you. We're going very, very slow for a reason, because it's the same stuff over and over again. Any questions so far? Plots are off. Nothing's highlighted. Nothing in y1, y2, y3. Good? How do I take this data, X and Y, and put it in my calculator? I'm going to take those X's, put it in list 1, and I'm going to take the Y's and put it in list 2. So how do I do that? All together, push stacked. Stacked. Write down whatever you need to write down. Then press number 1 for edit. Any questions so far? Have we done this before? Yep. Now, notice I have stuff in my list. Did I teach this last time? You can either delete the contents by hitting delete, which takes a little while, or you can go all the way to the top where it says list 1, hit clear, enter. But do not go to the top of the list and hit delete, then you delete the column. So we're going to go to the top, hit clear, enter. So everybody make sure there's nothing in list 1 and there's nothing in list 2. Yep. Are you missing a list? Yeah, because if you're missing a list, I can get that back. Again, if you have questions, let me know. Now, in list 1, we're going to put the X's. In list 2, we're going to put the Y's. Okay? Now, the X's are going to go in list 1. So we're going to hit 28, enter. 30, enter. 32, enter. 34, enter. 36, enter. If one number's wrong, the whole thing's wrong. You okay? List 2. 45, enter. 52, enter. 55, enter. 51, enter. 47, enter. Any questions? Okay, step away from the calculator. Now, more importantly than the calculator or anything like that is understanding the problem. So we haven't stopped and talked about the problem. What is X? What's X? Pounds per square inch. And what's Y? Mileage. I am not going to be able to see this thing unless I understand the window. So let's back up and look at the problem. If I wanted to see these points, I need to start a little bit before X, a little bit after X to figure out a window, a little bit before Y, and a little bit after Y to see a window. So looking at my X's, what's the lowest number? So what should I start with? 25, 20. Nobody said 0. Nobody said -10. We don't want to go too far. So let's go with 25. And what's the biggest number? 36. So maybe go to 40. So 25 to 40, counting by what? What's a good number to count by? 5. So 25, 30, 35, 40. Nobody told us the window. We figured the window out based on the data. Are we okay? Understand the problem. 25, 30, 35, 40. Now let's look at mileage. What's the lowest mileage? 45. So which should we start with? 40. What's the highest mileage? 55. So maybe go up to 60. So let's go back. What are we starting with on our Y? So on the corner, right on the corner, just like we did last time, the Y is starting with 40. How high are we going? 60. So what should we count by? 5s. So 45, 50, 55, 60. Again, nobody told us that, but do we understand the problem? What's our input? Pounds per square inch. What's our output? Mileage. We okay? Now this is going to be important in a minute. So back to the calculator. Step 1, put your data in the calculator. Any questions there? Step 2, everybody push second Y equals. Second Y equals. Notice you have plot 1, plot 2, plot 3. You can do 3 plots all on top of each other. We're only doing one picture. So choose plot 1, choose plot 1. Now plot 1 is on or off right now? On. So let's turn it on by pushing enter on. Push down, and you have 6 pictures if you push to the right and left. We want a scatter plot. Which of the 6 pictures would be a scatter plot? 1, 2, 3, 4, 5, 6. 1. So choose the first one. So let's make sure it's on. Choose the scatter plot. Push down. Where are my X's? So how do I do list 1? Second 1. Enter. Where's my Y's? Second 2. So to review, plot 1 should be on. Choose scatter plot by pushing enter on top of it. X should be list 1. Y should be list 2. You okay? Any help? Stop me now. It's easier to stop than to go backwards. You get to choose where you want the dots to be. Boxes, plus, or dots. I think the boxes are nicest. So step 1, did we put the data in the calculator? Yes. Step 2, did we tell the calculator we want a scatter plot? Yep. Step 3, window. Everybody push window. And this should be the easiest step because we've already done it. Look at your picture. What's your X minimum? X minimum, 25. What's your X maximum? 40. What did we count by? What was the scale? Good. What's your y minimum? Y maximum? And y scale. So it's very important that you sketch it first, and most important, understand the problem. Then hit graph. Once you hit graph, you should see the dots. Okay? Now, some of you are already looking ahead. So let's sketch what we have. 28 is 45. 30 is 52. 32 is 55. 34 is 51. 36 is 47. Now, what we're about to do is linear regression. And some of you are already saying, why are we doing linear regression? Linear regression is when the dots look like a line. Do your dots look like a line? No. What do they actually look like? A parabola. So which would be better? Linear regression or quadratic regression? So you're already ahead of the game, but I'm going to teach you both. So let's do linear regression first, see if it looks good. If that doesn't look good, we'll do quadratic regression. So I'm teaching 2 for 1. Okay? So everybody on your notes should have a picture. Okay? So how do I do linear regression? So how do I get to line? This one I'm about to show you is the same for linear, quadratic, exponential, quartile, cubic, log, natural law, or natural law, the same thing, and logistic, all the same stuff. Ready? Everybody push stat to the right for calculate. Where's linear regression? Okay, I want to ask one more time. Be careful. Where's linear regression? 4 or 8? Doesn't matter if you use 4 or 8. And the answer is no. I don't care if you use 4. I don't care if you use 8. But I'm going to warn you, 4 would give you, I'm going to make up an answer. 4 would give you y equals 2x plus 3. 2x plus 3. 8 would give you 3 plus 2x. Are they the same? 2x plus 3 or 3 plus 2x? Are they the same? Yeah. Do you want the slope in front? Choose 4. Do you want the slope in the back? Choose 8. They're both good. Let's just use number 4, because that's what you're used to, but they are the same. Choose number 4. Now, different calculators look different ways. If your calculator looks like mine, x is where? List 1. Second, 1. What's y? Second, 2. If your calculator's blinking, that's no problem. You got to put list 1, comma, list 2. So if it looks like mine, you do not need a comma. If it's just blinking, linear regression blinking, you have to put list 1, comma, which is above the 7, list 2. But everybody, when you hit enter or go down to calculate, should get this. I already know what you're going to say, don't say it. Does everyone see A? Does everyone see B? Is anybody missing R squared and R? Okay? For those that are missing R squared and R, it's a one-time only thing. You never have to do it again. All of you can do it if you want, but it's a one-time thing. It's just to turn on setting. If you're missing R squared and R, or if you just want to follow along, push second 0. Second 0 is your catalog. Everything your calculator can do is enter the catalog. Press and hold the down arrow, because we want that cursor all the way to diagnostic on. Diagnostic on. When you get to diagnostic on, put your little arrow on diagnostic on, hit enter, and enter again. And it looks like nothing happened. But if you do it again, stat, calculate, Number 4, you will have r squared and r. Okay? Now, why are r squared and r important? Either one, r is correlation, r squared is coefficient termination. Bottom line, the closer they are to 1, or 0.99, or 0.90, the better the line. Are either one of these close to 1? Would putting a line when dots are a curve be a good idea? That's what r squared and r are telling you. If those are close to 1, 99, 90, 80, whatever, it's good. Are these even close to 1 at all? No. But still, let's write it down. Notice they give you the formula y equals ax plus b. A goes in for A, B goes in for B. So they're telling you if you do linear regression, it'd be 0.15x plus 45.2. But when you look at those r's, they're kind of warning you saying, is that a good idea? Is that line really going to cross as many points as possible or reflect the data? Probably not. But to see it, everyone go to y equals. And under y1, put 0.15x plus 45.2. So what you did is your calculator took all those points and just like that figured out where's the best line that gets closest to the most points. It took every point into consideration, hit a graph, and that's the best it could do. And the problem's not the calculator. What's the problem?
The numbers.
Yeah, does the numbers, do they look linear? What do they look? Quadratic. So would linear be a good fit? No. But we know how to do it. Are we okay? And if I taught you linear, it's the same thing for quadratic. So let's do quadratic together. The same steps as linear. What's the steps again? Stat. To the right for calculate. Quadratic. Fine. Now keep in mind, linear, quadratic, cubic, quartile, all of them are there. So whichever one I ask for, the steps are the same. Quadratic's number 5. Make sure x is list 1, y is list 2. Hit calculate or enter. Now first look up to see if we all have the same numbers. And before I do anything else, look at the r squared. Is this a pretty good line or not so good? Pretty good. Why? It's close to 1. Okay? Better represents the data. So to compare which line is better, you look at the r squares. Okay? Now, look at the formula. I need to put in A for A, B for B, and all that. So how many places to round? I think 2 is appropriate, but the more decimal places, the better. So we're going to say y equals 0.52x squared plus 33.29x minus 480.94. So how many decimal places? 2, 3, 4, whatever you feel is appropriate. I think 2 decimal places is appropriate for now. Now, to make sure we didn't mess up and to make sure we understand what we're doing, go back to y1, get rid of the linear one because we know that's no good. Replace it with quadratic and see if it's better. Change y1 to the quadratic and see if it's better. So, everybody, y equals negative, be careful, 0.52x squared plus 33.29x minus 480.94. And to make sure I'm correct, when I hit graph, does it model the line? Not bad. Not perfect, but not bad. Much better than before. Are we okay? Now, ready for lightning round? Look up for me. I'm going to go through the slides, which you have access to, so if you need help, go back to the slides. Was the linear one a good idea? No. So we did quadratic regression. We did stat, calculate 5. So if I back up a little bit, sorry about that. How do you do linear? Linear regression, all the steps are here. Same thing we got for linear regression. We wrote down the equation, we graphed it, we did quadratic regression, we did stat, calculate 5 instead of 4. We got the same answers. We put it in a quadratic equation. Much better than before. Done.